Hello guys, welcome back to the channel. Today we'll be solving LeetCode 155 min stack. This problem is not in blind 75 of the LeetCode, but this is one of the important or good problem in stack that helps us understand stack. Uh, it is similar to like how stack is created, the data structure stack is created. We have already created a stack using arrays in C++. This is like creating an array but with an extra step, so we will be going through it in this video. So let's start this video without any further delay. So here's the question. Let's read the question before going into it. Design a stack that supports push, pop, top, and retrieving the minimum element in the constant time. So when we design the stack in C++, I will upload the link. I'll put the link in the description. We have already done in C++. So what we did was push, pop, and top. This has an extra step. We have to find get min. So this is just looking at the problem and taking a stack. If 1, 2, 3, 4 is in the stack, this is quite tricky in getting the minimum value because you cannot just go through all the values. You have to like to reach to 1, you have to like pop these, and like we can only get the top value, we cannot get like a random access. So this looks like a tricky one, but we can solve this question by creating two stacks. This is the stack and this is the minimum stack. So why we are creating the two stacks? Because we cannot like an array, we cannot have like a random access. We can only have the top access, and we can either pop or push or only access the value. The access, it is quite limited. The services are quite limited in the stack. So what we can do is we will have a stack like normal. We'll create like a normal stack which only gives top, pop, and push, and we'll have another stack which will keep the minimum value. So let's take an example. Let's take an example. -2, 0, -3. So we are responsible to input these elements. So we are pushing -2, we push into this stack, and this is minimum stack. So what we can do is we check the element of stack and the last value of minimum stack, but right now we don't have any value in the minimum stack, we just push in. So while entering 0, we enter 0 here, and we compare this 0 and last value of minimum stack, 0 and -2, whichever is smaller. -2 is the smaller here, so we'll push -2 here. We are just having a track of track of the minimum values. So now we'll push -3, and -3 is the smallest, we push -3. So this also helps during the popping. If we pop this, we also have to pop the last element of the minimum stack. So in the stack we have 0, and the minimum value in this stack is -2. So this is how we can find a minimum value by creating another stack. What we could have also done is create a 2D stack, just like stack and min stack. The 2D stack also contains double integer. This will contain stack elements, and this will contain min stack. In this question we'll be using two stacks for better understanding. So let's go to the coding session without wasting much time. So here we are in the coding session. So before starting the coding, let's write the algorithm. Two stacks. One contains elements like the regular elements, and another contains the min values. And both of the stacks are created using arrays or list in Python. Okay, so let's clear the class. Self.stack, self.minStack, now we push the value. If there is no stack or there is no value in the stack, we push the same value in the stack and minimum stack, as we have already discussed. Val self dot min stack dot append val. Okay, then else we just put regular elements in the stack. I'll just copy this so that I don't have to type every time. And here compare and keep the min value in min stack. Okay, if val is less than min stack itself, min stack, and that is like end value, self dot min stack dot append val. Okay, else we put the last element of the min stack. Okay, this looks good. And now we pop. While popping, we pop the last elements of both the stack. And top gives return self dot stack -1, and get min and top are kind of similar because what we did is we're keeping the minimum value on the top of the minimum stack. So okay, so this looks good. Let's run first to avoid small errors. Okay, this got accepted, and now let's submit. And yeah, runtimes look good as well, like 68%, which is not that bad. We are using memory is 20 MB, and memory is also not that bad while we are using like 2 stacks. So this is pretty good solutions. If you have any other ideas of how we can solve, I already told like how we can use the 2D stack to solve this problem. If you have any other ideas of how we can solve this problem, just let me know in the comment section. If you like the video, please like the video and subscribe for more content. And thank you guys for watching the video. Thank you.